Okay, so now I'm looking at the next section, which is where the exponential started. So determine whether it's a exponential function. This is, and it's because that negative is not a part of the base. It's just multiplied out front. Whereas number 12 is not, because the negative is part of the base. So that -3 is in parentheses, so therefore that is not an exponential function. Evaluate at the specific value. So we have y equals 4 to the x, and we want to evaluate it when x is 3. So 4 to the third power, 64, I believe. Maybe I should have a calculator. But yeah, that's 64. Graph the exponential function. So remember, when we're graphing, we're only using 3 points. So -1 would be 4 to the -1 power, which is 1/4. 4 to the 0 power is just equal to 1, and 4 to the first power is 4. So when I go to graph this, so my point -1, 1/4, 0, 1, and 1/4. And that is my exponential function. Number 15, we're converting to logarithms. So the base has to be the same as the base of the exponential. So we have log base 8. On the other side of the equal sign is always the exponent, 1/3, and then what it was equal to just goes inside. So log base 8 of 2 is equal to 1/3. 16, we have a logarithmic, and we want to express it as an exponential. So again, this is the base, and this is the exponent. So 3 to the 4th power is equal to 81. Number 17, they want us to solve it. So we can take that logarithmic, rewrite it as an exponential. So 1/3 to the -4 power is equal to x. Now that negative exponent tells us that we're taking the reciprocal. So 3 to the +4, get rid of that negative exponent, and then 3 to the 4th power is 81. So 81 is equal to x. We want to write this as the sum or difference of logarithms. So I'm going to expand it all the way out. You shouldn't have any exponents, radicals, so all we can have is the coefficients in front. So starting with the top, I have log base 4 of x to the 6 plus log base 4 of y to the 5th. And then this stuff down the bottom, there has to be a subtraction. So log base 4 of z minus log base 4 of w to the 6/5 power. So remember, when you have an exponent that's a fraction, the top is the power and the bottom is the root. So now I'm just going to go through and multiply all these exponents out front. So multiply them all out front, and this is completely expanded form. So when you have a question like this, if you leave an exponent, if they're asked to do it all the way out, then that's going to be a wrong answer because you have to take that extra step. And then for this, we want to write a single logarithm. So we're going in the opposite direction. So now where we see a subtraction, we know that that was division. Just like when you have a multiplication up top, that's an addition. So I'm going to, first of all, bring that 2 back up. So we got log base b of x to the 5th minus log base b of the square root of x squared. Well, square root of and the square term, they just cancel each other out. So this is just log base b of x to the 5th minus log base b of x. And then that division we get log base b of x to the 5th over x, but that can be simplified. So my final answer is just log base b of x to the 4th. Find the value of the expression. So we have log base 5 of 1 over 25. So I'm going to rewrite this 1 over 25 as a power of 5. So 25 is 5 squared, and because that was in the denominator, it's going to be to the negative 2. And then that property tells me I can take that exponent and multiply it out front. So I get negative 2 of log base 5 of 5. Well, that's just equal to 1, because this means 5 to what power is 5. So my answer is just negative 2. Number 21, solve for y in terms of x. I'm going to put it together on the right hand side, so that would become log base b of 5x. And because they're both log base b and they're equal to each other, then we can say those arguments are equal. So we get y is equal to 5 times x. For 22, again, I can put these together. So I have log base 4 of y equals, so I have an x. That minus means that this term, the 9, is going to go on the bottom. And then that's pluses for the 2. So that also goes up top. So I'm just going to put it together. Log base 4 of x times 2 on top. So 2x. And then the 9 is on the bottom. So again, they're both log base 4. I can rewrite it with just their arguments equaling each other, and I get y equals 2x over 9. I really do need a calculator now, which of course I don't have. Alright, so evaluate the logarithms and round to the nearest tenth. I don't know that you actually have to use logarithms for this. I think you can just plug it right into your calculator, but I will do it out. So remember, we did the ones I did in class, you had to use logarithms because you got like overflow error or something. Here, I don't think you really need to, but I'll take log base 10. So we have log, I make it equal to n first of all, and then I'm going to take the logs at both sides. So we have log of 27.1 times 9th root of 92.8. And I can finish expanding that. So I have the log of 27.1 plus 1/9 times the log of 92.8. So plug those in your calculator. And then after you get that answer, you just have the log of n is equaling whatever that is. And then the last step you have to do is, because this base is 10, you'd have to do 10. N is equal 10 to whatever this is when you plugged it in your calculator. And I do know what the final answer is somewhere. So n is equal to 44.8. Sorry, this place is crazy. I brought some stuff home. I have stuff in boxes. I don't know where anything is. I don't know if your life is like this right now, but this is all I got. Alright, and then number 24, you're trying to find the antilog. So you're just taking that number, so 10 to the 0.4910 power. And that one was 3.0974 was the answer for that. Okay, so the last grouping, I'm going to have to start a new one. So 25 through 30, I'll put on the next recording.